Hi, my name is Megan Sturm, and I'm going to be talking about my work from this summer with the Tunnel and Duke RU program. So I was working on simulations of spin-dependent dihadron production for the EIC with Dr. Anselm Vossen and Christopher Dilks. So the EIC is the Electron Ion Collider, and it will be built off of RIC at Brookhaven National Lab, and it will collide polarized proton and electron beams. Right now they're working on a yellow report, which outlines the detector and collider parameters. So this involves a lot of simulations in order to design these things. So we were working on this simulation for Di-Hadron semi-inclusive deep inelastic scattering. So just a little bit of background on that. You have an incoming lepton, which exchanges a virtual photon with a nucleus, and then you observe your outgoing hadrons and lepton. So specifically with dihadron pairs, we get this extra observable, which is R, the relative momenta between the two outgoing hadrons. And this allows for 3 angle measurements. And this is important because, as you can see, the cross-section depends on the parton distribution function, but more importantly on the fragmentation function, because that depends on these angles phi r and phi h. So using this fragmentation function, we can extract the transversity from the outgoing particles. So our Dihadron plugin, so this was already made when I began working to identify dihadron pairs and electrons from the same scattering event, perform the kinetic calculations, produce a root tree. But I implemented some improvements on it. So the first is just pi0 reconstruction. So this allows us to now look at channels involving the pi0. Previously, since pi0's decay before being detected, they were not part of the simulation, but now they are. And I also implemented this generated smeared connection, which allows us to look at the resolution. And it allows us to do the third thing that I improved, which is the weighting scheme. So the weighting scheme allows us to identify the correct amplitude for smeared events based on their corresponding generated event. And this is helping us to create these asymmetry projections. So as I previously described, there are fragmentation functions that depend on the transverse momentum. And so you can kind of see that in that chart here. Like you have your different fragmentation functions depending on your quark and your nucleus polarization. So we observe these fragmentation functions essentially and transversity as asymmetries. And so on the right you can see some plots of asymmetry, and these were made using the plugin and the proper weighting. This is for pi plus and pi minus. But basically using these plots we can extract transversity. So thank you for listening, and thank you to the Tunnel RU program.